Hello everyone, this is Xibai, and here's my final research paper presentation. And my paper is Object-Oriented Programming in High-Performance Computing. First, we need to know what is the object-oriented programming. So it's a computer program model, and we learn in class, so we all know it. So second one is, what is the high-performance computing? It often uses GPUs, FPGAs, or other coprocessors, for example, Xeon Phi, to accelerate the computing speed. Next one is the background. So more and more people or developers use the object-oriented programming, and the high-performance computing is gradually becoming known. So what if we combine the object-oriented programming and the high-performance computing? So what will happen? Why not do it? So here's my outline. So first we introduce the GPU architecture. So here is the NVIDIA GPU architecture. It has many CUDA cores and L1 cache shared memory and L2 cache global memory, constant memory. It is like the architecture with the CPU. So, but there are some different. The most different is the L1 cache, and the L2 cache is small. It's very small than the CPU, and the cores is there are many cores. The number of cores are much more than the CPU. So this is the difference between CPU and GPU. And the data transfer. Here is the how we use GPU to computing. So we need to transfer the data from the PC, from the main memory to the GPU. The GPU have a device memory, so we need to transfer it. For example, we computing something on the GPUs, we need to copy the memory from the PC to the device. And then after we have the result, we need to copy the result from the GPU to CPU, back to the CPU. Back to the main memory, to the PC. So it is on the bus through the PCIe. And the second one is the object-oriented programming in C++. So there are many differences between object-oriented programming and the procedural programming. So first is the class versus the structure, and the new versus malloc, and the vector versus array. So the first one, the class versus structure, it is the same on the memory, for the memory. So which means we store the data or the things in almost the same in memory. And the second one is the new versus malloc. It is the same to the memory too, but it is some different, but it's not the most important. And the next one is the important one is the vector versus array. So for the architecture or for the memory, they are quite different for vector or arrays in real project. Because if we use the vectors, we may maybe use the 3D or 2D vector. So in each vector, we need to know in the 2D vector, we need to know many vectors. The first vector is the vector of pointer, and then we knew the vectors in different memory. So in object-oriented programming, the memory of the vector are separate in different place of the memory. And if we use the procedural programming, we just we just malloc a 2D array, so it is consequence. So that's the difference in memory between the object-oriented programming and procedural programming. So next is our experiment. So we build a benchmark. So we compute the A1 to A8. We multiply A1 and A2 and A8 and 8 arrays and save the result to the C. And the first one is the procedural memory. So it is the I plus the west and like this. And so my environment is the 64-bit Windows 10 Virtual Studio 2019, and my GPU is the 1080 Ti. And the result, so we first compare the computing time. So for the 8 arrays performance, which means we separate the arrays in different memory, which means the non-consequence memory is the GFLOPS per second is 2.06, and the time is almost 0.03 milliseconds. And one array performance is almost have the same time. I ran it in 2 times, and for each time, the number of iterators is 30,000. So it is almost the same, which maybe a little confused. We in my mind is, I think the one array performance should be more quick than the 8 arrays. So what's the wrong? So that is because the memory copy time is the different. Because each time we computing on the GPU, we need to copy the data from the PC to the GPU. So the memory copy time, we need to consider it. So we compare the memory copy time, it is quite different. So if we mem copy the 8 arrays separately, it takes it costs 0.25 milliseconds. But if we copy one array memory, which means we copy one time, but 8, the size of the memory is 8 times than the first one, which means we copy the same size of memory, but the first is 8 copy in 8 times, and second is copy in 1 time, because the vector we can't copy 8 vectors in 1 time. So it is quite different. So it is almost 3 times speed different. So before the conclusion, I can run it for here. So first we build a solution. And here is my compare. Okay, build success. And we start without debugging. Okay. So the 8-arrays computing is almost the same as the 1-array computing time, but the memory copy time is quite different. Because we opened Zoom to record, the speed is a little bit slow. And here is it. So the conclusion is that using 8 arrays and 1 arrays don't have obvious difference in computing time, but have almost 3 times difference in memory copy time. So what's the future? I think we can do more experiments on benchmarks or real projects, which means compare the difference between the vector and the sequence array is quite simple or quite small. So we need to compare the difference between the difference in real project, which means we take object-oriented programming project and we rewrite it in procedural programming, and we compare the result between them. And the second one is we can compare other aspects between the object-oriented program and the procedural program, maybe the function calls. So the function calls waste a lot of time in CPU computing. So there are some difference between the object-oriented programming and procedural programming in the function calls. So that's my presentation. Thank you.